Hi, I'm Luke Kane. Welcome back to Algebra 1. Today we're going to talk about the point-slope form of a line. Last time, or actually earlier in the course, we studied the standard form of the equation of a line, ax plus by equals c, where a, b, and c can be any real number. And then we found more recently the slope-intercept form of a linear equation, and that is y equals mx plus b, where m is the slope of the line and b is the y-intercept. Today we're going to learn yet another form of the linear equation called the point-slope form. Okay, so here we have a line plotted on a Cartesian coordinate system. Now let's be given a point. All right, a fixed point. Let's call it x1, y1. Now, in this particular graph, we actually know what the value of x1, y1 is. We can find that by counting 1, 2, 3, 4. So x1 is 4, and 1, 2, 3, 4. y1 is 4. So the actual coordinates for this particular point are 4, 4, but we don't care. Let's suppose we don't know them. We're just going to assume that this particular point is fixed. It's a given point. Now let's pick another point. Now this point, in contrast, is not going to be fixed. This point can represent any point on this line. So right now it has coordinates that have a few more decimal places than x sub 1, y sub 1. And notice the coordinates can change because this point can represent any point on this line. So it can drift down towards negative infinity in the x and y direction, and it can bounce back towards the positive infinity direction. It doesn't matter. The point is that this point, x, y, represents any point on the line, and this point x1, y1 represents just one point. Alright, so here's my line. This is my fixed point. This is the point that's given. Alright, it'll be given by the problem. And this represents any point on the line. Okay? Now, if we remember the equation for slope, it's the change in y over the change in x. Alright, so we have a point x1, y1. We have another point x2, y2. And the change of y is given as y2 minus y1 from the coordinates above, and x2 minus x1 from the coordinates above. Well, let's just call this x2, y2. And we already have an x1, y1, simply so we can plug in to the equation. So I get m equals, well, y2 is just y, minus, well, y1 is y1. And x2 is just x. x1 is, well, just x1, so it's minus x1. Now, I want to get rid of this denominator, so I'm going to multiply by x minus x sub 1. Of course, if I do it to one side, I have to do it to the other side. Alright, this is itself divided by itself. That's just 1. 1 times anything is anything. So on the left-hand side, I get y minus y sub 1. And I'm going to flip this because the convention is to put the m in front. And I can do that because multiplication is commutative. It doesn't matter whether I multiply 2 times 3 or 3 times 2. I'm still going to get 6. So this is x minus x1. And another convention, the y tends to go up front on the left-hand side and all this other stuff on the right-hand side. So I get y minus y1 equals m x minus x1. This is the point slope form of the equation. And basically, as the name implies, if you're given a point, say 2, 3, and you're given a slope, say slope of 4, and you're asked for a line, or you're asked for an equation of a line, that passes through the point, with the given slope. Alright, it's just plug and chug. It's not a really difficult problem. So you're going to end up with y minus, well, this can only be x1, y1. There is no x2, y2. Oops. 2, 1. There we go. So y1 is 3. M is 4. Well, x is x minus x1, which is 2. Of course, I can manipulate this if I want. I can make this into any form I like. If I distribute that, I get 4x minus 8. Y minus 3 equals 4x minus 8. Add 3 to both sides. And what do I get? I get y equals 4x minus 5. And now I have the slope intercept form. All right, and I could change this so it looks like this: ax plus by equals c, and that's the standard form. And I could do that by just rearranging. That's not a big deal. So that's the formula that you should write down, put in your cheat sheet, commit to memory, whatever, because it's something you're going to need to do computation in the final, in the test, in the quiz. Okay, so what did we learn? We learned the point slope form of the equation, which is y minus y1 equals m times the quantity x minus x1. x1 and y1 represent a point that's given, and m represents the slope that's given. So when do you use this point? Well, obviously when you're given a point and a slope, and you're asked for the equation of the line. Next time we're going to start talking about system of equations. I'm Luke Kane. Thanks for watching. Bye now.